Hello, Middle 2. Our lesson today talk about graduation of element properties in modern periodic table. So we must treat atomic size and the electronegativity and metallic and non-metallic property. The first one is atomic size. What's meant by atomic size? Atomic size is atomic volume. That means we measure the atomic volume of atom. So it can measure by picometer. Again, the atomic property can measure the atomic size or the atomic volume. That means we can measure the volume by measuring unit called picometer. And we must know about the graduation of element in period and graduation of group in the graduation of element in the group. In the period, we move from left to the right. As the atomic number increase, the atomic size decrease due to increase the attraction force between positive protons or positive nucleus and negative electrons increase. But in the same group, as we move from up to the down, the atomic size increase and the atomic number increase. So the relationship between them is directly proportional. What's meant by directly proportional? That means increase together and decrease together. But in the period is inversely proportional. What's meant by inversely proportional? That means when increase, the another one decrease. When the decrease, the another one is increase. So in the same period, the atomic number increase, the atomic size decrease. And in the same group, the atomic number increase, the atomic size increase due to increase the number of energy level. To know about the graduation of the metal and non-metal or the element, lithium and sodium and potassium is example for element in group 1A. So if we move from up to the down, we know that the electron in outermost energy level is 1. So it's a group called group 1A. But in the lithium and sodium and potassium, lithium have 2 energy level. And sodium have 3 energy level, and potassium have 4 energy level. That means if we move from up to the down, the energy level increase, so the atomic size or atomic volume increase. So in the group, as the atomic number increase, the atomic size increase due to increase the number of energy. In period, we have a phosphorus and sulfur and chlorine and argon. Phosphorus and sulfur and chlorine and argon have the same energy level. All of them in period number 3. But we have the different electrons in outermost energy level. Phosphorus have 5, silver have 6, chlorine have 7, argon have 8. So as we move from left to the right, as the atomic number increase, the atomic size decrease due to increase the attraction force between positive nucleus and negative electrons. So we have a 15, we have a 16, and the another one has 17, and the another one have 18. As we move from left to the right, the number of electrons increase, so the attraction increase. So the atomic size decrease. Second one is electronegativity. What's meant by electronegativity? The electronegativity is the ability of atom in covalent molecule to attract an electron toward itself. That means when the difference between atom and another in compound is greater than can called polar compound. If the difference between electronegativity is low, so it's called non-polar compound. What's meant by polar compound? It's a covalent compound. The electronegativity between them, the difference between electronegativity between them is relatively high. So if we talk about the water H2O, then we have two hydrogen atom and oxygen, and the three atom is linked together, and oxygen have electronegativity and have ability to attract the electron 3.5, and the hydrogen have ability to attract electrons 2.1. If we difference between them, we have a 1.4, so it's relatively high. And another example, in ammonia, nitrogen have ability to attract its electrons 3, and hydrogen have ability to attract electrons 2.1. So difference between them is 0.9, so it's relatively high. Another hand is nonpolar. It's a covalent compound. The difference between electronegativity is relatively low. So if we have CH4 called methane, see, we have a carbon and 4 atom of hydrogen. The carbon have ability to attract electron toward itself 2.5, and hydrogen have ability to attract electrons 2.1. So that the difference between them is 0.4, so it's relatively low. It's called nonpolar compound. Another example, hydrogen sulfide. It's H2S. We have two hydrogen linked or attached to the sulfur. The ability of sulfur to attract electrons toward itself 2.5, and hydrogen, its ability to attract electron toward itself is 2.1. So the difference between them is 0.4, so it's relatively low. Again, we have polar and nonpolar. Polar, the difference between electronegativity is relatively high, so it's called the polar compound. When the difference between electronegativity is relatively low, it's called nonpolar compound. The another one is metallic and non-metallic property. We have 4 kinds, as we said before: metal and non-metal and metalloid or semi-metal and inert gas. So we gonna talk about the 4 sections in metal, non-metal, metalloid, inert gas. Metal, element that in outermost energy level less than 4 electrons. Less than 4 electrons, 1 or 2 or 3 in outermost energy level, tend to lose during the chemical reaction and change it into positive ion. And the electronic configuration in this state is similar to the electronic configuration for inert gas that preceding or the follow that preceding. The metal in ion state have the same electronic configuration for inert gas that preceding in periodic table, like lithium and sodium and calcium, magnesium. Lithium 2, 1. Lithium lose the electrons in outermost energy level, so it's changed into positive ion, lithium plus 1. And sodium is the same, 2, 8, 1, have 1 electron in outermost energy level, so change it into positive ion and change it into Na plus 1. Calcium have the same electronic configuration but have 2, 8, 8, 2, but lose the electrons in outermost energy level and they change it into positive 2. Magnesium 2, 8, 2, lose the 2 electrons in outermost energy level and they change it into magnesium plus 2. The other hand is non-metal. The non-metal element which in outermost energy level more than 4 electrons, So we have a 5 or 6 or 7 electrons in outermost energy level and tend to lose or tend to gain during the chemical reaction and change it into negative ion. So the electronic configuration of non-metal in ion state is similar to the electronic configuration for inert gas that follow them in periodic table, like carbon and oxygen and phosphorus and sulfur. Number 3 is metalloid. Metalloid called semi-metal because we have the pose of property of metal and non-metal. Okay, inert gas, the last one, located in 0 group. The inert gas is inactive during the chemical reaction, so it's called inert gas. Let's summary. Metal and non-metal and metalloid. Metal less than 4 electrons changed into positive ion like potassium and sodium and lithium and so on. Non-metal more than 4 electrons and they changed into negative ion like chlorine and fluorine. Metalloid have both properties of metal and non-metal, and for example silicon and A. The next one is graduation of metal and non-metal in periodic table. In group and in period. In the group, as we said before, by increasing the atomic number, the atomic size increase due to increase the level energy, and is the same. By increasing the atomic number, the atomic size increase, so the metallic property increase. What's meant by metallic property increase? The atom have ability or easy to lose the electrons easily. And inversely proportion or in opposite hand is non-metallic property decrease, like as we show in the group. If we move from up to the down, the atomic number increase, atomic size increase, the metallic property increase, the non-metallic property in decrease. Sorry. In period is opposite. In period, as atomic number increase, the atomic size decrease, the metallic property decrease, but non-metallic property increase. So, as we move from left to the right, each period starts with a strong metal and then disappear, and appear semi-metal and disappear, and then appear strongest metal. Non-metal one is 7A. 7A is the strongest non-metal. So, as we summary, in the group, atomic size increase, atomic number increase, metallic property increase, non-metallic property decrease. And in period, the atomic number increase, the atomic size decrease, metallic property decrease, the non-metallic property increase. One is 7A. And to show the chemical properties for metal, we must know about the chemical reaction for metal in some properties. Like we must prepare magnesium strip and test tube, dilute hydrochloric acid. What's meant by dilute? That have a little of water, and small piece of copper. We put magnesium in tube and the copper in the another one, and pour another hydrochloric acid, both of them. We note magnesium react with hydrochloric acid and the hydrogen gas evolve in the form of bubble. And copper doesn't react with hydrochloric acid, so the hydrogen gas can't evolve. Number 2, heat a piece of magnesium strip and the iron, so till glowing. So put both in a tube filled with oxygen. We note magnesium state the violet litmus paper into blue. Change the color of litmus paper from violet to the blue. And another one, add a drop of water, both of them, and shaking. Okay, while shaking, the iron tube substance formed which doesn't dissolve in water, but in magnesium strip or in magnesium state, the substance is dissolved in the water. So conclusion, some active metal as magnesium and zinc react with acid and form a salt of acid and hydrogen gas. Number B, metal react with oxygen forming metallic oxide. Metallic oxide, what's meant to metallic oxide? That means metal link it to the oxygen, so it's called metallic oxide. And have another one, another name, basic oxide. And some of metal oxide dissolve in water form alkali. When the metal oxide dissolve in water, it's called metal hydroxide, and so the solution is alkali solution. And turn the litmus paper from violet to the blue. Again, when the metal react with oxygen, it's called metal oxide. That have another one, basic oxide. when this basic oxide dissolve in water, form alkali solution, which turn the litmus paper into from violet into blue. But another one doesn't dissolve in water, so it's can called alkalis. So we have Mg plus 2HCl give magnesium chloride and hydrogen gas will evolve. And magnesium react with oxygen, so give magnesium oxide. Magnesium oxide, this is metal oxide. And when iron react with oxygen, it's give iron oxide. When the magnesium dissolve in water, it's give magnesium hydroxide. When the magnesium hydroxide, when put litmus paper, violet litmus paper, its color changed into blue. It's fair. Then we note another properties for metal, its chemical activity series. What's meant by chemical activity series? That means we arrange the metal according to descending order, according to the reaction of metal with the water. So, like potassium and sodium react with water fastly, with hydrogen gas which evolve with pop sound. And calcium, magnesium react very slowly in cold water, and zinc and iron react with water at high temperature only, water vapor. And copper and silver don't react with water. Again, potassium and sodium react fastly with water and give hydrogen gas which evolve. Calcium, magnesium react very fast, very slowly in cold water. Zinc and iron react in vapor, water vapor, and at high temperature only. Copper and silver don't react with water, In another hand, we have a chemical properties of nonmetal. Nonmetal don't react with dilute acid, like carbon and sulfur doesn't give any reaction. And nonmetal react with oxygen, forming acidic oxide. But metal react with oxygen, give basic oxide. Again, nonmetal react with oxygen, give acidic oxide. Like carbon react with oxygen, it's give carbon dioxide. And when burn a piece of coal in the air or by oxygen, it's change the litmus paper into red. And acidic oxide when dissolved in water, forming acidic solution, and which change the litmus paper into red. Like carbon dioxide when dissolved in water give carbonic acid. Carbonic acid is acidic solution. And some elements such aluminum oxide, Al2O3, called amphoteric oxide. What's meant to amphoteric oxide? That means aluminum oxide or some of metal react with another one, like react with acid as a base and react with base as acid. When another one is base, it's deal with another one is acid. When in the front of base, it's deal as acid. And both of them give. To summarize the whole lesson, in group, atomic number increase, atomic size increase, the metallic property increase, the non-metallic property decrease. But in the period, the atomic number increase, the atomic size decrease, the metallic property decrease, the non-metallic